Next is a technical session on embedded devices, security implication on industrial control system, security assurance levels. From the perspective of IEC 62443 standard by Mr. Moon Eluvangal.
Hello, thank you for introduction. Today I'm going to take this session on this embedded devices security and its implication on this ICS SALs, and it is from the perspective of IEC 62443 standard. Okay, so I would also like to thank ESSS for giving me this opportunity to take this session, and that's very important when this OT security thing is means getting a lot of means hype nowadays. Okay, so I once again thank ESSS for giving me this opportunity here. Now we move on to the agenda of today. So today we are going to cover about what is OT. So before that, I'm trying to set a background or set the context. Okay, then we move on to discuss about what does OT mean and what is the importance of OT. Okay, and then I will quickly brief you about the different embedded devices which are used in this OT. Then move on to the security standards, more specifically IEC 62443 standard, and how is it applied, means from a security assurance point of view. And then finally, how the embedded devices security can help to reach that SALs. Okay, so this is a very brief agenda that we are going to take you through today. So what does it mean by OT? Okay, so so OT is nothing but what you see in the factories around you or any production facility. Okay, it may be a car manufacturing plant, it may be a water treatment plant, it may be an oil production or an oil refinery, it may be a mining company. So you can see OT in all these facilities, right? And so what is actually OT doing in this facility? Okay, so there is a manufacturing process running in all these production facilities. Means when I say process, it means converting from the raw material to a finished good. Okay, so for example, in the car manufacturing company, you can find engine shops, paint shops, then similarly in a cement factory you can find a quarry, then the limestone comes to a crusher, then from the crusher it goes to a furnace, then to a kiln, then to a cooler, and then it goes to a packaging. So these are the different processes, examples of different processes in a cement industry. Okay, so these processes are means automated using this the OT systems. Okay, so the cyber physical systems which are involved in the automation of the manufacturing process is called as OT, and of course there will be a network associated with those cyber systems, right? And we can see OT in, like I said, in every factory, and it does exist in the critical infrastructure industry like oil, energy, transport, pharma, etc. Okay, so means like so here what is the most important thing to note is like the difference between OT and IT. I mean, when I say OT, it involves the physical processes like a robot picking up something and putting it somewhere else. Okay, but in IT network, or when we say IT, it is all a computer-based system. Means there are not physical system involved. So that is the main difference between IT and OT. Quickly, I want to just give you that difference. Okay, so in my previous slide, I mentioned about the cyber physical systems. Okay, so what does it mean by those cyber physical systems? Okay, so the physical system, I already given you an example, a robotic arm. Okay, it is a physical system. Another examples are valves which control the flow of the fluid, a boiler, a temperature sensor, a motor, and there are so many physical systems. Okay, and these are controlled by some logic which is running in a computer-based system, which are called cyber, which is, that is why I called cyber. Okay, and this includes the normal servers and workstations. Okay, and different softwares running on top of that, like SCADA, HMI, etc. And you can also find embedded devices, okay, which actually control these physical systems through something called as IOs, okay, input output. And also, like I said, there is a network involved which connect all these devices together. Maybe it may be an Ethernet based network, or it may be another physical media which are used, like Profibus, etc. Okay, even CAN bus also we can see in sometimes in the plants. Okay, so this is what I meant by cyber physical systems. Okay, and now I'm quickly moving on to the embedded systems which are used in OT, or the plants. Okay, so like I mentioned in my last slide, embedded device includes the programmable logic controller, or also called as PLCs, and numerical relays, remote terminal units, edge gateways. So what does it all do? Okay, so these devices are programmed in some way. Okay, and it controls the physical systems. So for example, I am taking a substation which actually gives you the electricity to your house or industry. Okay, so there is something called as a breaker. Okay, which when breaker is opened, then there is no energy transmitted. If it is closed, then the electricity is transmitted. Okay, so it can be an automatic control wired to the breaker. Means when there is a fault detected in the system, suppose a earth fault or some kind of fault, then automatically the breaker is opened. So that is done through a program. Okay, and means using this either numerical relays or remote terminal units. Okay, sometimes it is a manually from the software, SCADA software, somebody clicks a button, then also this is operated. Okay, so these are the means different embedded devices used, and I just briefly mentioned the purpose, right? And mostly we can find the real-time OSs are used in these embedded devices, like it may be Unix based OS. Sometimes it may be means like VxWorks or other popular, mostly the real-time OSs are used in this embedded devices. And it comes in a ruggedized hardware to cope up with the EMC, EMI's conditions in the plant or in the substation, because there will be a lot of electromagnetic interference and electrical interference. So this hardware should have that compliance to meet or to live in that environment. Okay, and when I come to the communication side of these devices, it mainly use the industrial protocols, which are not which means which is very different from what we see in the IT world. Like IT world protocols change, means not daily, but maybe every year sometimes. Okay, and it is improved and new features are coming in. But in the OT world, the protocols are very legacy, very old, and the revisions are means like very rare. Okay, and some of the protocols that we can find in the OT or the embedded devices are like Modbus, Ethernet IP, DNP3, Profibus, 650, etc. So then moving on to we already covered what is meant by OT, or that it is something which we can see in a plant, production facility, and the role of embedded systems in that OTs means, or the manufacturing plants, right? Then I am slightly moving towards security of the OT. Okay, so why, what is the security? Why we need that it to be very secure? Okay, So OT security has become a hot topic after the Stuxnet event, which happened in 2010. Okay, so at that point, the world realizes that the impact of an attack on a OT systems is much larger than it is on an IT. Means like if a bank is attacked, we lose some money, but if an attack, successful attack on a nuclear plant, you can imagine it can even cause a war, or it can also bring down a country. Okay, so that triggered, like post 2010, all the people started looking at it with a very importance. Okay, even means I could read few days back that it is one of the topic in the World Economic Forum that is going to happen in June. Okay, so that is the keynote even on this topic on OT security. Okay, so as an means a very quick example that I can give you is some event which happened in 2021 August, when when an attacker was able to hack a water utility SCADA. Okay, so he was able to change the recipe of a chemical mixture which is used to treat the water. Okay, so we can imagine if it was successful, then nobody could have stopped it if the water means have flown to the households, right? But fortunately, it didn't succeed. The operator in the plant immediately noticed it, and he was able to stop. So summarizing, it is not means OT security or an attack on a critical infrastructure is not as something hypothetical. It is happening already, and it is increasing. From, if you see a trend for last 10 years, it has been increasing. So this is a quick slide which gives the important attack which have happened since 2010, and also on the bottom if we can you can see the incidents which were recorded by ICS CERT in US. Okay, so all these attacks means like some of them were very targeted attacks, specifically to target an OT system. Okay, but some of them were accidental in the sense that it was a attack on IT, or in some malware breakout, or like for example the WannaCry. Okay, so but it also impacted the OT system. The next slide, in which I have highlighted the attacks which have happened in the past, which utilize the embedded systems, or the attack successfully was able to change something in the embedded system, and it caused a damage. Okay, so this three which I've highlighted is not the only ones, but these are the three ones which came to my mind, and I highlighted it. Okay, so I will maybe quickly explain what have happened in some of the attacks involving the embedded systems. For example, in Stuxnet, means like there's a long history. Means like it was the first point of attack happened through a USB drive. Okay, so through the USB drive, some the malware get into a nuclear facility in Iran. And what it did is it changed the program of a PLC, which was controlling the centrifuge of the reactor. Okay, and the PLC, the changed program was running on the PLC, but the operator was seeing it as before. Like his screen was intact, running as what it was before. It was not giving any alarm or any malfunction, but the program running inside the PLC, the embedded device, was not the actual one. It was tweaked. I mean, so it was modified. Means PLC program, which was modified logic, which was running inside the PLC, and it was causing the reactor centrifuge to stop in every 30 days. Okay, and when it's means like it stops in 30 days, means it was actually trying to damage the centrifuge. So it stopped in every 30 days, then they will restart, then again it stops in another 30 days, then they started to realize that something is going wrong. Okay. So the point here is like, so the program which was changed in the embedded device. Okay, so if there were proper security control in the embedded or the PLC, it could have been stopped, right? So that is what. So it involved the embedded system, or it take the advantage of the PLC to cause this attack. Similarly, in another, the Ukraine power grid. So this happened in 2015, not after the recent Russia-Ukraine war. It was much before that. So where they were able to again, means first they get into the means the servers, okay, used in OT. From there it was able to go into the remote terminal unit which controlled the breaker, from the example which I just mentioned in the previous slide. Okay, so so the controller or the remote terminal unit was malfunctioning and it was operated remotely. Okay, so so all this gives, means like, it means that the embedded systems which are used in OT is a vital component, and it can be attacked to cause a huge damage. Okay, and one important point to note here is these three attacks, which involve the embedded systems, were a targeted attack on the OT facility. Okay, so it was, all these were not accidental attacks, but these were very targeted. So it means that when somebody is targeting, mostly by the state sponsored, like some espionage, right? Like in that scenarios, they target the embedded device. Okay, and those who make those specific malwares have very detailed knowledge of the embedded systems, the RTOS running inside this, and how it operates. All this means they have a very detailed knowledge of the systems, and based on that, they are developing these malwares. Then coming to the standards, so which have again evolved after 2010, means like the different international bodies realize that there's a different standards are required to defend the OT systems. Okay, and most important ones which are being used are NIST 62443. Then there are some standards which are country specific or region specific, like CPNI, ENISA, and so and so on. Okay, and one of the most important is 62443, and I'm going to a little bit explain more about 62443 today. So 62443 is a very vast standard. It contain, as of now, it have nearly 13 different standard documents, and it is actually classified into four different buckets, as you can see here. The first one, which is one series, 6443-1 series, which gives the general explanation about the glossary and terms which are used. Second series, 6443-2, which talks about the policies and procedure to be followed by the asset owners and the service providers. Okay, and 6443-3, which talks about the security of an ICS system. Okay, when I say ICS system, so it is ICS and OT. I am using it means interchangeably. Okay, so when I say ICS system, it is not a whole plant. So if you consider a plant, it may have different ICS system, like I mentioned in the beginning about the process where you have paint shop, machine shop, engine shop, etc. And inside that you will have maybe a robot, a conveyor belt, a packaging unit. You know, if somewhere else you can see a boiler. So that is an ICS system, a boiler or a packaging unit. Okay, and so dash 3 series talks about the security of such a system. And dash 4, I think some of the sessions are already been there on dash 4 in the same conference, which talks about the security of the components, or for us, the embedded devices. or also sometimes the softwares, firmwares, etc. Okay, so the 4.1 basically talks about the security life cycle, secure development life cycle, and 4-2 talks about the security requirements for an embedded device. But today, my point of interest is Dash 3 series, and how it is used to assess a plant, an ICS system, and how we achieve those required security levels. Okay, so that is my point of interest today. So yeah, so yeah, moving on to a little bit detail of 3-3, means as you can see in 3-3, there are different security levels defined like SL1, SL2, SL3, and SL4. Okay, so what does it mean? So there are altogether 100 different controls in 3-3, and if you meet, I think 25 of them, which are the basic one, you are at a level called as SL1. Okay, then if you meet next 25, I think not next 25, 50, next 50 of them, then you reach a level called as SL2. So the first 25 and next 50 means total 75 controls you have to met so that you reach an SL2 level. Okay, then there are next 15 to reach SL3, and next 10, so total 100 controls, then you are at SL4. Okay, and standard itself define, if you are at this particular level, you can defend this particular kind of an cyber attack. Okay, so how we are using this 3-3 in a real world scenario? Okay, so I will use this example, means which I have used in the past, or some of my colleagues, friends are already using uh, to assess a factory or a manufacturing facility. Okay, so the 3-3 means, like I mentioned, it defined different SL security levels. So we are called in by the asset owner to assess their plant. Okay, and we have to determine at what level they are. Like, so we conduct an assessment. Okay, and we rate them, like we say that you are at SL1. Sometimes it may be less than SL1, so we even call them SL.5, SL.8. Okay, so they are not reaching up to SL1 also. Okay, so then once we determine an SL, and we also find out what should be their target based on the criticality. Okay, so a boiler which may be very critical to a plant, we say that this should be at SL3. Okay, so so once we determine that target, okay, so then we chart out the mitigation or the solution that should be mapped to meet that particular target. Okay, so that is what you can see here. So we are saying that if you have to reach SL1, then you should implement all these particular controls. Okay, all these particular solutions. Okay, so yeah, we do an assessment, and then we determine the current security level, and then we also means try to find out, or sit with the customer and figure out what should be their target, and in order to meet that target, what should you change. Okay, and one important point to note here is, this is an example, this is not a full complete list, but you can still see one line which talks about the controller hardening. Okay, so which means that they already have some controllers, some which are basically the embedded devices that should be reconfigured, or sometimes even that embedded device or the controllers is not having enough capability to reach that particular target. Okay, so we are saying that yeah, you should either change that particular controller, or you should reconfigure, make some configuration changes, and so that you can meet the particular security assurance levels. Okay, so this is an example how we use 62443-3 in an assessment, and also to mitigate, so that the asset owner can improve the security of the plant. Okay, So I want to focus here is about the role of the control means of the embedded systems which are used in OT. Okay. So here basically, yeah. What are those requirements for the embedded devices so that it can achieve certain security levels or security assurance levels? Okay, so most of them are mainly those are like authentication and authorization controls. Okay, so for you have an embedded device, so it should have proper authentication and authorization controls built in to that particular embedded device, encryption, password strength, firmware signing, user roles creation, audit trail. So these are the important controls that should be built into that embedded device so that it can reach the particular SIL requirement for an ICS system. Okay, so if you have to meet a particular target, then the role of embedded system is very important. So the embedded system should have that capability, and it should be properly configured in order to meet that particular security assurance level. Yeah, so now I will take you through the Excel sheet which explains all these controls which are used and how it is classified with the authentication authorization or all these requirements for an embedded system. Okay, so here I will try to explain you about the controls using this Excel sheet. So in 62443 3-3, we have got nearly 100 different controls, okay, which you can see in this column, column E. And here is a little bit of description of that particular control. And here it is the associated security level, okay. So out of this 100 controls, uh, many of them are applicable for the embedded systems used in OT, okay, where I have put this yes. Okay, so it means that if a particular ICS system need to meet a security level, then the embedded device involved in that particular system have to need to comply to these particular controls. Okay, so like I mentioned in the slide, it is mostly around the authentication and authorization, encryption, firmware signing, etc. Okay, so also one of the attack which I mentioned about the Stuxnet, in which the program was changed in a PLC. So all this happened because of lack of this type of control. Okay, if we have to meet a particular SIL, then the embedded devices used in that particular system has to be either configured properly. I mean, sometimes it also happens like the passwords are not configured or the proper encryptions are not used. So first, one important thing is configuration. Second is the device itself should have that capability. So the device vendors should look at this 3-3 standard also from a security assurance point of view. Okay, but because most of the time I have seen the dash 4 standard is being followed by most of the vendor, but I believe 3-3 is also very important. Then only we can achieve a system level assurance, only if the components used in that system have that compliance. So finally, this is my last slide, which actually summarizes what we discussed means in the past 30 minutes. So to it means that means I already given you a flavor of what is OT, and OT security is very important in the post Stuxnet era. And embedded systems are definitely one of the vital component, and the weakness in the embedded systems have been exploited in the past. I already given you an example. And what we use 3-3 standard of 62443 to review and assess the manufacturing plant security assurance level. And we have found that there are a lot of dependency with the embedded systems used in OT. Okay, so basically, what the point I want to make here is beyond 62443-4, that is which is the main focus of this embedded system developers vendors. They should also try to map to the requirements of 3-3 so that the plan can meet certain security assurance level, okay, which is required or as per the industry standard and the criticality of the plant. So with that, thank you for